Hello and welcome. I'm Chuck Chapman. I'm going to walk you through the Mojave installation. We're going to walk through the unboxing. We're going to walk through the physical installation of the unit on the wall, the necessities of the building or location you're going to be putting it in. We're also going to go through the electrical connections to the grid, to the backup loads panel, the grid direct PV and how it's connected, as well as a generator. So let's go ahead and get started. This is ESS training, and there are requirements behind that. Working with energy systems, you always need to protect yourself. So always be sure that you wear OSHA-approved eye protection, hand and body protection, use the proper equipment that goes from insulated tools to lifting equipment and moving equipment, and calibrated and verified meters. And the most important thing to remember in safety is you. Make sure that you are properly trained, make sure that you are properly outfitted, that you've read all the manuals, and that you're ready to install. Again, the installation is very simple. The mounting, we'll go through some considerations there. Wiring, we'll talk about the different items that are necessary for that. And then finally programming, which will help you get the unit up and operating. So the first thing I'd like to do is introduce you to our Watt School line that's available from our website. There's a link here. And what this is, Jorge is going to walk you through how to receive the unit, what to look for in the shipment, how to inspect it. Then he's going to go through how to unbox it, the paperwork that you need to keep, and then the items that are included with the ESS, the items that are included with the inverter, how they're used. And then he's going to go through, show you how to unbox the units properly, how to properly carry the inverter. That front door is very expensive, and if you don't quite hold it right, you may end up buying a new one. Jorge's also going to show you how to get the battery, the ESS component, unboxed, how to properly get it onto a carrying unit, and how to deliver it to where it needs to go. So remember, when you install this, you're likely going to be under the umbrella of an authority having jurisdiction. This is going to be an inspector who's going to come in and look at it. So first of all, make sure that it's installed by a licensed electrician who can be verified by the local AHJ. Another important thing is make sure that it only has one neutral ground bond. If you have more than one, weird things happen. This even happens sometimes when they hook up generators. But if you see weird things happening, just make sure you have one neutral ground bond. Mojave was designed for residential deployment. So install it in an area that is non-occupied space. This would be like in a garage or a closet, but make sure that it's away from like heat generating sources. Make sure that it's above the where you'd expect floodwaters to come in if you need to raise the floor, but make sure the floor is sustainable to hold the battery, and also make sure that it's level. Do not overload the Mojave. It just goes without saying. Inverters work great. We have a good surge capacity on this one, but don't operate it in a surge element all the time. Just not good for it. The current release Mojave is designed to work on the US 120/240 split phase system only. This isn't 2 drops of a 3-phase. This is the only thing it will work on. 120/240 AC. Won't work in Europe. Won't work on 50 hertz. What we're selling today is 120/240 split phase. Mojave will open the grid and the load when not powered. So in other words, when you are not powered, you will not have any input to the Mojave. You will not have any output from it. If you go into rapid shutdown, again, it's going to open the contactors related to the grid and related to the load. So it's a really good idea to put in some form of bypass switch. Another aspect of this is that you have to remember that every input actually has the ability to have AC on it. So the grid has AC on it, the generator could have AC on it, even the grid direct PV, if things go wrong, whatever, you want to make sure that you're always doing the proper lockout tagout procedures. The grid input circuit should support both the loads and what Mojave needs for charging, so size that accordingly. Speaking of sizes, this is the Mojave dimensional slide. So the battery system is 44 inches tall, 24 inches wide, and 12.5 inches deep. This allows it to fit easily upon a garage return wall, which is generally at least 2 feet. So the inverter will fit on top of it. Again, it is 38 inches tall, 16 inches wide, and 11.5 inches deep. The two will line up using this pass-through and this pass-through typically, with a chase in between. Weight-wise, the Mojave weighs 455 pounds. You'll definitely need assistance in moving this one around. And the inverter charger is 133 pounds. That will require a two-man lift or assistance in that department as well. So kind of talking about what a return wall is, let's go ahead and talk about how it would look if you deployed it in a garage. So this is a typical garage, and the return wall is actually the space between this wall and the garage door. That's called the return wall. Problem with this actual installation is that I'm putting it in the middle of an egress point, which I don't really want to do. And also, this is an inside wall. I'd want to mount it on an outside wall. So we'll talk about that. But let's go ahead and get this thing mounted first. So first step is we'll go ahead and drop the Mojave in place. We're going to hook it into the main panel, and then the next thing we're going to do is put in a backup loads panel. Now again, remember, there's a lot of things that fall into the NEC on this, so the backup loads panel actually can't be directly above the unit. You're going to have to slide it off to the side. Now, NEC says you need 30 inches of space around a device and that other devices can share that space, but it's important you don't have to reach over a device like the Mojave ESS battery to reach the backup loads panel. So again, this all looks good, but important things to remember per the NEC, you do not want to put this in an egress point. You do not want to put this on an inside wall, and you want to make sure that all the panels are spaced accordingly. So it's not a big deal, just something to note. So let's go ahead and take a look at the actual install. So Mojave's designed, the brackets are designed with a 16-inch on-center deployment method. So there are points on each bracket where it will mount to a stud. These 2 points here, these 2 points here, and both of the battery retaining brackets are designed there. Now, you do notice that there's some wood here. Generally, if you were going to do this, you would probably put it on put a wood wall in the front of it, a backer board. And then, if not, you might put bracing behind it if you were in a pre-construction phase. So, important things to note is that the first height is 78.2 inches above the ground. So again, our floor needs to be level. So we're going to make sure our floor is level. We're going to make sure the proper height is available in the ceiling. And then we're going to put our mounting bolt, our first one, at 78.2 inches above the ground. Then we're going to go 4.1 inches above that. We're going to drill in our second one. At that point, probably use a level, make sure that it's all set to go. And we'll actually walk through those steps. So the first thing you're going to do is mount that. Then you're going to go 44.6 inches. You're going to put in the bolts for the ESS. Again, these will be lined up directly on the studs. And then finally, what you're going to want to do when you put the unit up on the wall, go ahead and use a level, make sure that it's level, and then put in the second wall studs. Now, important things, studs have to be 16 inches on center. I would suggest you use longer bolts than what we provide for doing this particular part of the install. And the one thing that I always ask people to do too, if you put up a backer board or if you have bracing behind it, these screws have to go in again, maybe a 2-inch, 2.5-inch lag. Then use our remaining bolts to back it and put it in place. The reason I mention this is that this unit's going to be in place for 10 years, right? It's got a 10-year warranty. I don't want to be revisiting it because it's getting loose on the wall or something silly like that. Okay, now that I have everything mounted, let's go ahead and do a two-man lift. We're going to lift the Mojave up. We're going to drop it in place, wiggle it around a little bit. It'll drop onto that bracket. And as you notice here, again, I have a backer board, I have my drywall, and then I have my stud behind it. My lags here go all the way through the plywood. So they go through the plywood and they land in the stud. So you want to make sure that you have very good attachment at this point. Now again, to take a look at a real install, this is how it looks. If you notice, you can see just the head of the bolt on the side. Now, granted, I'm looking in kind of from the back, but if you're looking at it straight on and you've mounted it properly, in the center of these two bolts, this bolt and this bolt will just slightly be showing. So it's a good thing. we have a good video on the installation that Jorge put together. That video will walk you through doing this, and a note at the end, he'll tap it off to the side. You want to make sure you get the bracket fairly close, because if you tap it off too much, you're definitely going to see those bolts from the side. Once you get the top in place, then go ahead and mount to the bottom. So once you're done, it's level, secured. There are 5 more screw locations. Of course, this one is actually behind the metal plate. But you'll go ahead and put those in place. So, like I said before, we have a Mojave Watts School video available on the website, and this will take you through all the applications. He'll talk about how to mount it, how to put it on the stud, walk you through, do the actual installation. This is an important step here. The inverter needs to be 6 inches above the batteries. If you make it 7 inches, these are going to be too short. If you make it 5, you're not going to be able to get this in there. So you need to make sure that you have 6 inches between the 2 units. He'll show you where to measure this up. Another alternative method is to measure 33.58 above that. Again, he uses a level, puts the unit up on the slide, slides the battery in underneath it. I would suggest you do it in that order, because it's very hard to reach over the battery to try to hang the unit. Here he's bringing it in, making it level on the 2 sides, and then he's putting in those last securing bolts that we talked about. One item I left off is to put in this chase. The only thing I'll tell you on this is make sure you protect the top of the battery. You don't want these screws dropping into your ESS compartment. Let's take a look at the next section, conduit installation. There are 2 portions to the inverter charger. There's the upper portion, which is the inverter charger, and the lower portion, which comprises the balancer system. This is where all the electrical connections are made. To enable that, we actually have conduit knockouts. These knockouts are on both the right and left hand sides, as well as the bottom. There are 4 knockouts that are 3/4 inches in diameter, designed to fit a 1/2 inch conduit, 1 knockout that's 1 inch, designed to fit a 3/4 inch conduit. Now, to be honest, most of the time when I've done this, effectively you do the knockout and then you use a punch out tool to enlarge it as needed. And again, that's the right side. This is the left side, again showing the 4 3/4 inch knockouts, the 1 inch knockout. On the bottom, very similar. The items highlighted in green are for AC connections. Again, there are 4 3/4 inch knockouts and 1 inch knockout. There's also a 2 inch opening in the very bottom. This is for the battery. These are all the DC connections. So the only thing running through this should be the DC ground, the negative, the positive, and whatever CAN bus or other connection that you need. A temperature probe should run through that adapter. There are no knockouts in the back, though. One item to highlight is that this section in the back is where the DC wiring generally goes. This section is actually covered up by a metal plate in the front. You can, of course, drill out and try to put your own knockouts in the back, but just be aware these sections may be difficult to run wire through. Lastly, there is the top of the Mojave. The top of the Mojave will have no connections. You cannot run wires through the Mojave inverter section in order to connect it. That'll violate your warranty and UL as well. So important things to note is that energy can flow in many directions within Mojave. Based on the connection, the system will limit current flow, and to use NFPA Table 9 for conduit usable space, and NFPA Tables 9-5 dimensions of insulated wire to help you in determining the wire and the size of the conduit you need for the installation. So connecting the system up, if you're connecting it to an existing GDI system, remember that there's existing MLPE electronics that'll be in place. There'll be a disconnect, a backfed breaker in most cases. Of course, there are taps and different things that you can do outside of this. So the first thing you're going to have to do is, of course, disconnect and move the conduit as necessary, put up your backer board, put up your backup loads panel. Then you're going to populate the backup loads panel with the same backfed type of circuit breaker. Move the disconnect, make sure to get the rest of the conduit in place, and then install your Mojave system. Finally, connect your Mojave up to the backfed breakers in the main panel, and you're off and running. The same thing holds true for string inverters. You'll have your string inverter in place. Again, just do what you have to do in order to get into the wiring, put up a backer board, a backup loads panel, populate the loads panel with a backfed breaker, install the disconnect as needed, install additional conduit, the Mojave system, and then turn on the backfed breaker. This takes care of the string inverter. Again, they're very much the same. Big thing to remember, 8 kilowatts is the maximum amount of power that you want to push through this. One last item, NFPA NEC 70, the 2020 version changes some of the rules related to ESS and the requirements for emergency disconnect. So what I would suggest is that you leverage something inside the Mojave called the rapid shutdown. You have a couple of different options from Outback for rapid shutdown initiation devices, both our ICS and the IMO options. So if you note here, I have my disconnect in place. It's outside of the building, readily accessible. It's able to be locked out. I'll tie this into the rapid shutdown connections on the inside. If you watch here, what I'm going to do is I'm going to turn the little knob here, and you'll see my Mojave will go dark. So effectively what this will do, this will drop the grid input and the output breakers, the generator breaker effectively, and shut down the inverter. At this point, you would also probably have to disconnect the grid direct PV shutdown as well. If I turn it back on, everything returns to normal, battery turns back on, inverter turns back on. Make sure everything's operational, close the breaker on the grid direct PV. So kind of looking at how we're going to do this, if you rotate down that top panel, I'm just kind of looking at it from the looking up. There's a multi-connector that's in the very back of the panel. Just take that multi-connector out, put it where you can see it. There's going to be a jumper that's going to attach the rapid shutdowns. So what you're going to do, we're going to take it, we're going to remove that jumper. We're going to install our wiring between pins 5 and 6. By pushing in the little tabs, inserting the wires as needed, and then we're going to reposition this back, plug it back into the system. Now my rapid shutdown is in place. Connecting the battery to the inverter, of course, you want to make sure the battery breaker is off. You want to make sure the inverter is off and that all sources have been terminated at their source of origination. Just make sure that you lock out, tag out the main panel so that you don't have AC running through it. So when you go to connect it, you're going to remove this top panel. So the top panel of the battery is where all the connections are made. So remove this front cover by removing the 5mm hex heads that are inside of it, the 4 Allen heads. Then access the connection. You're going to run your wires as needed between the inverter and the battery. You're going to have a 4-aught plus, a 4-aught minus, a 4-gauge ground cable, and a CAN bus, which will be a Cat5. There is an installation of an additional cable for the battery ground. This is kind of showing you a front visual of the negative and where it attaches in the system, the positive where it attaches, the ground wire and where it attaches to the back plane. The one thing not shown yet is this little wire here included in the kit. You're going to install that between the negative terminal and the ground bus. If you don't do that, the inverter won't see the DC ground that it needs in order to operate. So you want to make sure you get that jumper in place. Easiest thing is to use the one that's included in the system. And then finally we have the purple wire, which is our CAN bus connection. All the cables need to be torqued properly, the positive and negative between 65 and 75 inch-pounds, the ground to 35 inch-pounds, that's both ground connections. I'll show you what it actually looks like in reality. This is a non-populated cabinet. So you see my negative terminal standing up here, positive terminal standing up here, my ground, which goes to the chassis here, and then my connection where my CAN bus would go. When it's finished connected, this is what it looks like. So effectively you'll see my negative is coming down from the inverter. It's tied directly to the negative terminal, and then the ground is on top of it. That's your stack. And then you'll put your securing washer and tighten it to the torque specifications. The positive, same thing. Bring the positive down, connect it. Make sure that your neutral ground is in place. Make sure that your inverter ground is taken up. As you notice, it can go through either side of this connector. So in my case, it was easier to do it from that side. And then finally, I have the extra wire looped around, but this is my CAN bus connection. So effectively, again, positives connected, torqued. Negative connected, torqued. Grounds are all made as needed, and the CAN bus connection is made. What you do not want to do in this system is unplug, disconnect, or modify any of the other connections in here. The next step in the battery assembly is to put the covers back on. So what you'll first do is take your cover that you removed, cover N, place it over the unit. It'll latch in. There's a couple of little tongues on the side it latches into. Then take cover number O, place it over that. That's the LED bezel. Then place the middle cover M on the unit. Again, when you put it in, use the 5mm screws, but don't tighten them. Then finally put the lower cover on. Place the 5mm screws in. Don't tighten them. Once they're all in place, then hand tighten the 5mm screws. So let's talk about other batteries for a second. Mojave is flexible, but there are requirements of the batteries. 48 volt DC strings. So a lot of batteries are 12 volts. If so, put them in a string of 4. You'll have your 48 volts. You then can put them in parallel as required. Demand pushes the quantities. The more demand you have, or the longer time you need to run, you need to increase your battery size. There are detailed settings under each setting. There are other constraints, FLA, AGM, TTPL, VRLA batteries. They're rated in ampere hours. They require a temperature probe. There is 3-stage charging for those, and then venting is required with FLA generally. Best practice for putting them in parallel, and make sure that you understand the depth of discharge. The further you take them down, the more you reduce the life cycle of the batteries. There's also out-of-band lithium. These are rated in kilowatts. There is a minimum requirement to not overload the BMSs in these batteries and trip them. There's no temperature probe, but lithium does have a temperature range. And those are normally supported through 1 or 2-stage charging. In other words, just a bulk, possibly a short absorb, but no float charging of the lithium batteries at all. So other batteries, just taking a look at them, we have a lot here. Like I said, Mojave's flexible. This is an example of the Energy Cell PLR. It's a VRLA, AGM, TTPL battery. It's rated in ampere hours. Again, minimum 3-stage charging. And again, the higher you take them in discharge, the shorter their life cycle. We also have the Energy Cell XLCs. Again, these may already be in place. All you have to do is go to the drop-down. You can effectively connect to these. These are some of our FLA batteries that we have, the Energy Cell FLAs. Realize that these may be 6-volt batteries, not 12. Therefore, you'd have to put 8 in series. Again, the demand pushes the quantity. They're rated in ampere hours. As being flooded lead acid, you will have to vent them. And one thing to show you is that Mojave does have a function. Mojave does have a function that allows you to bulk start, EQ start, or stop both the functions, so that flooded lead acid batteries are not a problem for Mojave either. When we look at some of our best batteries, you're looking at the NSB Blue batteries. These are a VRLA, AGM, TTPL, nanocarbon. Lots and lots of features in this one. These come in 12-volt batteries. There's going to be 4 in a string. Again, hook as many in parallel as you need to. They're rated in ampere hours. They require a temperature probe. And again, they require a 3-stage charging. The nice thing is that these batteries are very rugged. They work very well. One thing you'll notice is that I've taken the ampere hour settings and actually converted it to kilowatt hours. These kilowatt hour settings are actually based either on cycle capacity or standby capacity. Cycle capacity, you can see in the notes down in the bottom, is 25 degrees C, 50% depth of discharge. So that's your cycle count for those. Then if you look at the lower setting, the potential capacity is much higher, but that's taking it down to 80% DOD. This is for more of a standby use. So these can be configured in any way, very, very easy to set. All you have to do is go down to the drop down, pick them out, and you're all set. Again, we also support our larger batteries, the RE high capacity. Again, there are 7 selected standards. What you're going to do, though, is you're only going to pick the 48-volt setups. There's a 20-year design life on these with 1,800 cycles at a 50% depth of discharge. 100% out-of-the-box initial capacity and up to 2,000 ampere hours per cell. These are very large battery cells that are strapped together. They can be configured in either 2, 3, 4, or 6 cells wide. So depending on the cabinet and the arrangement you need, you can rearrange them to fit in whatever application you need them to fit into. Again, they can be very large banks, anywhere from 12, 24, 48 volts DC up to 1,000 volts DC. Other lead acid batteries, so if you have a different kind of lead acid battery that is not listed on it, you can just put in the ampere hours. There's a setting that you go into in the unit to do that. It will require a temperature probe and follow best practices. If it's not defined outside of this, maximum 3 batteries per string. One of the nice things we have is the Outback System sizing tool. You can get it off of our webpage. I just clicked on the link here. Really easy. If you're looking to set up something, you go in, you choose the application. Is it energy management? Is it emergency backup or off-grid? So you pick what you want. Let's just pick energy management. Then it's a split phase, 110, 240. You choose the appliances that you need to run, the quantity, the watts that they're going to pull, how many hours a day they'll be running, how many days a week, and if there's a surge multiplier. Same thing with CFL bulbs, compact fluorescent bulbs or LED bulbs, how long you're going to run them, and depending on the bulb, it may have a surge multiplier. And you go through and you can add additional things in there, but like you can add a row. Let's choose something else. I'm going to choose an appliance here. Let's say a 25-inch TV operates. It's 150 watts, operates 4 hours a day, 7 days a week, and then there's no surge multiplier. Once you get it done, then hit calculate, and it'll tell you the systems that'll work, including the Mojave. So this will tell you how you expect the Mojave to work, and the number of solar charge controllers, of course, will be whatever AC coupled solar charge controllers you have. So that is the one type of sizing tool we have. We also have another kind of sizing tool. It's found at this website. Same website, it's our Outback website, but this is actually a downloadable tool in Excel. It allows you a lot more flexibility, and you can also size other components like your solar array to charge controllers and other things like that. It's a very nice tool. Again, it's available on the Outback website. Just come here, download the sizing tool. It'll save the Excel website or web sheet, and then you can go through and use it as you need to. So go ahead and close this. So that's other lead acid batteries. Other lithium batteries, we do support the Simplify series, the Blue Ion, the Discover. We go through. The nice part is there are additional values that you can get. They're preloaded. You just simply put in the battery count. So in here, this is an example of the Simplify 3.8. All we do is increment the number of strings, which in this case would be batteries, because it's a 48-volt string. Put them in, and then you hit submit, and you're ready to go. Also, on the Mojave battery, it's really simple. You just simply go to the bottom of the website, to the bottom of the dropdown, and select Mojave BMS, hit submit. It'll come up. Normally, when you first plug it in, you don't even have to do this. You simply plug it in. When the unit fires up, if there's no other batteries that have ever been defined, it will default to this battery. The only things you set on this is your max SOC and min SOC. Click submit. If you change to a different battery, or if you selected the wrong battery and had to go back to the ESS, when you do, these values might be 100 and 0. Just set them according to what you need to set them to. So moving on from batteries, let's just take a quick look again at connections. So we do have the battery section down here with the positive, the negative, the ground, possibly a remote temperature probe or a BMS CAN interface. You'll have an Ethernet that'll be plugged into a router, or it could be wireless. The rapid shutdown we discussed. The generator we're going to discuss in a future slide. And then our coupling to the grid, effectively our line 1, line 2, neutral, and ground. You'll also have your CTs in this. There is a neutral ground bond shown here in the diagram. Again, this is the single neutral ground bond. There is none at the generator. There is none at the backup loads panel. As we move across, again, there's your backup loads panel and your back-fed solar inverter. So it's really simple. This is right out of the planning guide. So very simple to use. There's also a really good video, again, another Mojave video. This will go through, walk you through each one of the things of wiring it. So Jorge will show you the ground side, Effectively, he'll talk about the neutral ground bond, then he'll talk about the battery wiring, bringing in the line 1, bringing in the loads on line 1 and 2, then the addition of a generator. He'll talk about the multi-use connector and the connection of the CTs. Now, if you notice on the CTs, there's an arrow, that's current direction, and then there's also a label on it. Follow the directions on how to insert these. He'll show the low voltage connections like the CAN bus. Now, a couple of extra things that are outside of that video. First of all, our breakers will handle 60 amps. That's what they're rated. You can see it on the front. There's a wide range of size of wires that it'll handle from number 8 to number 3. All of the AC conductors must be copper. All of the AC conductors must be rated for 90 degrees C or higher if they're inside the cabinet. And our seizure is a little different. We have what's called a moving clamp style. So if you look over here at the breaker, you'll see this white outline, which kind of shows this silver device that would be moving. So when you tighten the screw, this is actually what happens. You're going to bring that in on the wire. Now this is a look from the underside up. Now that may look like a lot of fun, but it's not. So they're not like the general typical breakers that you're used to using. They're a little different. But all you have to do is there's a small bracket here on the back. This bracket can be removed. So what this bracket does back here is that it allows you to remove the DIN breaker. Now remember, these are dual gangs, so there's two of these little settings here. Pull down on both from the front. You can just reach back there, possibly with an insulated screwdriver. Pop one down, pop the other one down. The breaker will release. Then you can look at it, put the wire in it, and tighten the screw to make sure you clamped it correctly. When you look at the ground is super easy to hook up to. We provide a bus in the bottom of the Mojave chassis. You'll see a large green wire here. There could also be a secondary large green wire. The one would be from the battery compartment. There'd be another one from your panel, and another one going to the other panel if that's the way that you routed your grounds. All conductors again must be copper. The size ranges are 14 gauge to 1/0 gauge, and all of the conductor torque settings are set right there based on its size. This is right out of the manual. So they can enter from either side, and again, remember, they're different torques. The screws are designed to be either flathead, ECX drive, Robinson drive. On this next slide, we're going to connect up all the items, going to walk through and show you where each connection is and how it works. So first thing I'm going to do is drop the cover on the unit. So I'm going to drop the front cover, exposing the inside connections. And as you see from the power line, we have our neutral, comes from the transformer. It's bonded in our cabinet. Then we take our neutral over and we attach it to our neutral in our Mojave. There's one neutral line that goes up to the inverter. The other one goes to the other backup loads panel. And in that backup loads panel, then it services all of the split phase loads here. Power, same thing, come off of a backfed breaker. We have our line 1 and line 2, which again will carry up into the inverter. They come out of the inverter on the other side through the AC board, and then these two outputs go to the input of the backup loads panel. Our grid direct PV then attaches. Our grounds are carried through the whole system. Now let's talk about if we wanted to hook up a generator. First thing we want to do is remove the top cover. There's 4 screws. It's not a radian. They're not a ton of screws. It's actually just 4 5mm hex bolts. Pull those out, take them out, and what you'll see is that you'll see the AC board. There's already 5 connections there, right? 2 inputs and a neutral and 2 outputs. So what we're going to do is we're going to install our other 60 amp breaker. We're going to run the wire, of course, from the generator, neutral, line 1 and line 2, and then take our line 1 and line 2 up to the AC board. We're going to connect them up to the generator. We're going to look at that panel and pull out this device right here, this multi-IO connector. There are 2 connections for a generator. The top 2, 1 and 2, are a 12 volt DC option. They are polarity, so make sure you get that correct if you have a DC driven unit. And then 3 and 4 are the auxiliary relays. And when that auxiliary relay is put in place and closed, the generator starts, the AC board flips over to the generator, everything's fine. We here at Outback work with generators off-grid all the time. This is an excerpt from the manual showing the start and stop reasons. The system is fully automated as far as the generator goes. You can run manual, but these will be the situations that you may run into and the reasons that the generator may or may not be started. So the next thing is a battery check. Confirm your connections are tight. Close the ESS breaker. Push the button momentarily in the ESS, and then check for connection at the base of the inverter. You should see between 50 and 52 volts. Everything looks good. Go ahead and close your breakers for grid input and load output generator if you need to, and you're off and running. CTs are more sophisticated than you think. The wires have to remain twisted as much as possible, and directionality and connection are very important. CTs will have 8-foot leads. They can be extended another 12 to 22 feet for a total of 30-foot maximum with the same gauge cable. Always remember, keep the wires twisted. Make sure that they're wired correctly and installed correctly. These will help you with your self-consumption features. CTs are L1 and L2 based. So you see here on the connector, there's an external CT plus on 9, external CT 1 minus on 10, external CT 2 plus on 11, and external CT 2 minus. So it's very important. Think of DC wiring when you connect them up, so the black wire actually will be the negative, and there is again an L1 and L2 phase. If you're using from the grid, that'll show you a negative CT wattage. If you're selling to the grid, that'll show you a positive CT. And if you'd like to push loads or load, let's say, control over to the main panel, you'll have to use CTs. Next, let's take a look at the Mojave power interface options. There are hardware interface options on the unit. This would be the circuit breaker, with the grid breaker, the load breaker, the generator breaker, the ESS breaker. So these are all the on-site hardware controls. There's also an on-site web interface available through a Wi-Fi device. That'd be 192.168.2.2. And then once it's hooked into your network, you'll be able to reach it from anywhere within your local network using the IP address it's assigned. Finally, it will be talking to Optics RE and will be sending information northbound. So just taking a look, almost any device will provide access. I'll show you that in just a second. The interface device needs to be in the same network as the Mojave uses. It has to be either connected to the AP or connected to the Ethernet client. It needs to host a supported web browser. That's Firefox, Chrome, Microsoft Edge, Safari. It has to have a human interface device, in other words, touch or mouse or keyboard. And then, of course, power, either battery line or off of a charger. And then you can mount it. It can either be handheld, tabletop mounted, or wall mounted if you want to put one right beside the Mojave. Once it's in place, it'll start to transmit its information. Now, again, this is just an example of some quick screenshots of all the different GUIs that you get. As you can see, there's a cell phone image on the side as well as a computer image. And the part of that I'm showing here is that they both can be used at the same time. It doesn't matter that you're doing different things on different units. Just make sure that if you understand if you're making a change somewhere, it will show up on the other units as well. So in order to connect to the web, you need to connect to the Mojave AP using whatever interface you're using. Look up the Mojave, you'll look up the Mojave underscore and its last 3 digits of the serial number. Then enter in the Mojave, that'll be all the last 8 digits of the inverter serial number. And again, access to the direct Mojave page, open up a web browser on the device and browse to 192.168.2.2. So looking at the web interface operation, there are several sections. You have on the top section is major navigation, that's status, settings, events, and actions. Underneath that, once you click on something, you'll be able to go into it. You'll have a submenu of inverter, battery, grid, network, generator, and admin. And then underneath that, you have what you want to do. So there's a series of drop downs that you can get to. And then finally, you'll put in your input. To connect up and get more information. So let's say that I go to my Mojave. I've logged into it, 192.168.2.2. This is the way I set it up. I go to settings, I go to network. I then choose whether I'm wired or wireless. I choose DHCP, and then I connect. Once you get into it, again, you have to understand, is it wired or wireless? What's the IP address, the net mask, the gateway? And one of the important things to look at in the status page is the DNS entries. So make sure that you have your DNS entries, and when you go to provision it into OpticsRE, make sure that you grab the MAC address from the very bottom. Once you're connected to OpticsRE, you'll see that it's running. Connected and running. So again, major navigation done across the top using status, settings, events, and actions. And then minor navigation is under the tabs of inverter, battery, grid, generator, network, and admin. And then finally, you have the data sections underneath that, and then the control sections to do each data. Looking at the power flow graph, the arrows indicate direction. There's tiny arrows at the end of each one of these. Also, a couple of other things that are kind of important to look at on this is the icons. So I'll highlight the arrows for you. This is the power flow chart. It's shown here in the power flow. Then we have the icons for the inverter, the battery, the loads, the grid, and the generator. So we have all those. There are labels just in case you don't understand what the symbol is. Then there are values. So each unit has, or each designated power source has a value assigned to it. And that goes also for the kilowatts as well as the voltage and frequency, the percentage of state of charge and battery, battery voltage. So they're all shown. And then colors indicate, is it good, is it moderate, or is it bad? And they're very descriptive, very easy to navigate, very easy to understand. Then, so a couple of important items you have to do. So first, set up your grid profile. So go into settings, grid, select up your grid profile. The other settings that are important underneath that are the external CTs, whether they're enabled or disabled, your import limit, your export limit, and your charge from grid limits. And you may have to adjust these based on what the utility requires. Again, from the GIP menu, we support all of the normal GIP settings, 1547-2003 through ISO NE 2021, California Rule 21, PREPA, pretty much all of them. This is an example of all the settings that we show underneath that. The nice part about this, just the way I captured this, if you take the web page and you simply print it, you can then hand that to your utility to show how your system's set up and how you're complying with their requirements. Let's take a look at users and passwords. There are different user levels. Admin gives all controls. Installer gives access to almost all controls. Access to the GIP values is probably the most important one under the installer. And then the owner gives general access just for day-to-day use. The way you get to the different settings, you just click on the drop-down for user, select the user, and then enter the password. Now, again, admin gives all controls, all configuration, grid and phrase profile, firmware downloads. Password will be the last 8 characters. Change that on default. If you need to reset it, call us. For installer, it gives most of the controls, including the grid interface tab, historical information. Again, the default is the last 8 characters of the Mojave serial number, but the reset is done a lot like the way that our traditional inverters did the reset. Effectively, just send a message to Outback Power, supply the code that is shown on the web page, and then they'll supply you a temporary password. Finally, on the owner password, if they forget their password, it's even easier. You don't even have to interface. It'll pop up this message, and it'll tell you that it's going to flash the front panels. All they have to do is take a wireless device, stand in front of the unit, click OK, and it's going to flash colors. It's going to do just like this. So effectively, it'd be normal, and you'll see it'll flash red, red, and then it goes back to normal. So the password in this particular case is red, green, red, green. Simple enough. And beyond local management, of course, we have OpticsRE. Make sure you have an internet connection and your browser set up and that you have the address of the Mojave unit. You can get that from the web page as shown earlier. So log in, create a system as you need to, respond to the emails. Once you get in, select the system Mojave, enter the MAC address, and then you're going to be able to go in. The thing about the GUIs is that they are almost identical between OpticsRE and the GUI that's provided locally. That goes for the power flow diagram, the status of the items. Each item configuration is very similar. So once you learn to do one, you learn to do the other. Even the events logs are the same. And controls are shown under the gear icon in OpticsRE, under the actions menu in the Mojave. So let's go ahead and go interactive with the software. So the first thing I'll show you is that this is the Mojave web page. This is the local page, 192.168.2.2, is shown in the top. And you can see the Mojave web page, the power flow diagrams. It's simple to control using the mouse. I can click settings. It'll take me to the settings page. This is again where I would go into my network. I would set up my network for DHCP, put in my SSIDs, different things like that. And then I could go to the grid interface profile, changes that I need to, change the grid profile, whether my CTs are enabled or not, and then effectively go down and do that. And then finally I can go to my inverter, go to my time of use. I can set it up as I need to. And then under my battery, I can choose the battery. Of course, I'm running the Mojave BMS. It's all set. So the thing I want to show is that it's identical. So this is the network access, and all of the settings are identical to what I just showed you. There's no difference. If I go to OpticsRE, I see the power flow diagram. I see the device map. It all looks the same. And then I can go in and click on it. Or I can click, again, let me just go back in here, click on a system, and then it'll show me all of the settings. So pretty much you can overlay the two. And the other thing is that you're not limited to just this access. So what I have here, I have an iPad, as you can see, and I have an iPhone. And I'll show you how these two work. So here I'm moving the display on my iPad. Every time you access it with a new device, it'll pop up this tour, and you can go through and click End Tour if you want to end it. Then I can go into status, and while I'm doing status, I'll click over here on my iPhone, and I'll go into another setting here. I can go into generator, but you see they all work the same. So it's very, very easy to interoperate, both from a computer, from a tablet, from an iPhone, or from OpticsRE. Last thing we're going to discuss is stacking. So stacking is not really applicable currently to Mojave. It is going to be in a future development, but for right now, if you want to do stacking, best way to do it is to use our traditional products like the Radian. Configurations for the FXRs, there's a lot of flexibility that you can do in that. Parallel stacking, series stacking. FXRs also allow you to do both single phase, split phase, or three phase in the settings that are shown here on the page. Thank you. I appreciate your time and look forward to seeing you guys in the near future.